Okay, this is for Chapter 4, Section 3, called the binomial probability distribution. And what we want to do is the information we talked about in Section 2 on probability distributions, we want to take and examine in these next three sections, we're going to examine two specific cases. Sections 3 and 4 are devoted to the binomial probability distribution. And then section 5 is on another special one called Poisson's probability distribution. Okay. Now, the first thing you have to recognize is that because of a special nature, binomial probability distributions can be calculated only if certain requirements have been met. And that's the first thing they're going to ask you to do in the exercises. They're going to give you some scenarios and they're going to say, does this fit the requirements of a binomial probability distribution? Because if it does, then you can go on to perform some of the other calculations. If it doesn't, then you have to look for some other method. So it says down below there that you have 5 requirements for it to be a binomial probability distribution. Okay, first of all, the procedure has to have a fixed number of trials. Okay, so you're only going to do this thing so many times. The trials must be independent. Each trial must have all outcomes classified into only 2 categories. And then the probability of success has to remain the same in all the trials. Okay, I guess there's only 4, sorry. Okay, so a fixed number of trials. Trials have to be independent of each other. One trial cannot affect another, in other words. And the trials have to be either one thing or the other. And the probability of success can't change. And I'll explain that when I look at another episode here in a little bit. So once you've determined that it is a binomial probability distribution, then the next thing is we can find certain values for that exact value. So for each one of those by one of 3 methods. So we can find the actual probabilities, okay, for each one of these methods. Okay, so let's say, for example, and those are down here. Okay, so we'll talk about those now. They do have some notation. Okay, I want to point that out down here. Okay, so um, when they give you this P of S equals P, P equals probability, Q equals failure. You'll see that in some other things as well. P equals probability, Q equals failure. Now, notice that P plus Q has to equal 1. That's because there's only 2 possible probabilities. Either it works or it doesn't. Either it is or it isn't. 2 probabilities, P and Q. Okay, P is success, Q is failure. N is the number of trials. Okay, X is the number of successes that we expect to have happen in all of those trials. P is the probability of success, like we said above. Q is the probability of failure. And then P of X is the probability of getting X possible answers. Okay, now, like I said, you'll see that the reason they do all that there is the formula that we're going to talk about next contains those components. Okay, so the last thing on the bottom of that page, it says there's 3 methods for finding probabilities. I'm going to probably just focus on 2 of these methods, but there's the binomial probability formula. There is technology, and we're going to focus on how to use the TI 8384. There's a button for doing binomial distributions. And then there's a table. And I gave you a table. You should have a copy of the table with your packet of stuff for this chapter. Okay, and I'll show you what it looks like, how to use it. If you would happen to be missing that, then you can just use your calculator again. Okay, so on the back side, on the top of this worksheet, there is the binomial formula. Okay, and you can kind of see why I don't use it that much. Before I figured out how to do the technology, this is the formula that I used. Okay, and like I said, it's kind of cumbersome here. The probability of x successes equals n factorial over n minus x factorial times x factorial times p to the x times q to the n minus x. Now, the first part of that may or may not look familiar. That n factorial over n minus x factorial, that's the formula for finding the number of combinations. Okay, so what it's going to do is it's going to take the number of combinations times the probability of success times the probability of failure for those, and then use that to determine your final probability. So when you see how the calculator is going to work, you'll see it's much easier. You plug in 3 values and it's going to do everything else for you. Okay, so in the exercises, it's going to start right off. Determine whether or not the given procedure results in a binomial distribution. For those that are not, identify at least one requirement. Don't worry about doing that part. All I want you to do is write down binomial or not binomial. Okay, so number 4 is my first problem here. Okay. Okay, number 4 says, I'm treating 152 couples with a Y-sort gender selection method developed by Genetics and IVF Institute, and I'm recording the gender of each of 102 babies that are born. Okay, so there is a fixed number of trials. We're doing it 152 times. Okay. Well, okay, I guess they don't designate the success here, but the other key here is that's 152 different couples, and of the babies born, we know that they have to be considered either boy or girl. So there are 2 genders, okay? So that makes it binomial, okay? If we're looking at how many different options are available, okay, and it's more than 2, that's not binomial. So in this case, we've got a fixed number, and what I'm recording has 2 possible outcomes, all of them distinct, okay, and from that I can say, yes, this is an example of a binomial distribution. So on number 4, you would answer binomial. Okay. On number 6, number 6 says, "15 different governors are randomly selected from the 15 are selected from the 50 governors currently in office, and the sex of each governor is recorded." Okay. Now, there are only 2 outcomes, either male or female. Okay. But there's a problem with this. Okay. Since I have to choose, that word different here is creating a problem, and it will always create a problem. Okay. Because for 5 and 6 it will anyway, because every time I draw somebody out, if the 15 are different, that means that there is no replacement going on. Okay, so the events are not independent, and the probability of success changes each time that you perform a new operation. Okay, so that keyword different on 5 and 6 is causing a problem. It's basically forces that those 2 events are not binomial. Okay, they're not binomial because there is no replacement and the probabilities change here. So I'm going to write down not. Now, number 7, however, okay, it also says different, okay, but there's a problem here, okay. I'm selecting 500 different voters randomly selected from a population of 2.8 million. Okay. One of the things that it talked about on the front side is it talked about a 5% guideline. In this example, my sample that I'm choosing is so small out of that 2.8 million that it would not matter whether I replaced it or not. The probability of success would virtually stay the same because the sample is so small relative to my population. Now, the second part of this, it's asking yes or no, is he or she a Democrat? Okay. Now, they're not saying what political party are you, because if they did, you could say, well, I'm Republican, I'm Democrat, I'm independent, I'm libertarian, whatever. Okay. That means more than 2 options. That means not binomial. But basically, what they're asking, are you a Democrat? Yes or no. So by making it yes or no, then that makes it binomial. It's the number part of it that in this case, you have to be careful of. Will those probabilities for each event remain the same? Okay, so that's how you're going to answer those. Number 8 on the top of the next page is the same thing. Again, same idea. Okay, we're going to cross out number 9 and 10, questions 9 and 10 on that next page. And then I want you to go down to the bottom there on 11 and 12. Okay, for questions 11 and 12, and actually on the next page as well, this goes 11 through 16, I think. Assume that a procedure yields a binomial distribution with a trial repeated n times. Use table A1 to find the probability of X successes where given the probability P of success on a given table or trial, sorry. Okay, so what you want to do, this is how you use the table that I gave you. Okay, your table on the first page of this, we're gonna do number 12. N is 5, X is 1, P is 0.95. You want to grab this worksheet where this is your first, the title of the table, A1 binomial probabilities. Okay, now on number 12, you're given that n equals 5. N is right here. You follow it down to where it equals 5. The X then has to be 0, 1, 2, 3, or 4. So we want to find out when is N5 and X equal to 1. Now, follow that over in that same shaded row to where you get a column under the 0.95 for P. And it looks like we have a probability that is so small that we have to record it as 0 plus. Okay, so underneath that then, because of its position in the table, okay, number 12 is just 0 plus. And virtually what they're saying is it's 0.000, and then the rest of the digits are somewhere past here, but there eventually would be some. Okay, so that's what they're asking you to do on number 12, and the same is true on 13 through 16. Okay, the very first column has your n, Second column has your X value, and then follow it over to where you get your specific value to find out what column you're in. Okay. On questions 17 through 20, they want you to use the probability formula. Okay. I'm going to show you how to do it on your calculator. Okay. So on your calculator, okay, if you go to, I have to remind myself here. I went second, and then I went VARS, V-A-R-S. Okay. I get this menu. I'm going to arrow down to this Binom PDF. Okay. Binom PDF. And I'm going to hit enter. I ask for you the number of trials, the P, and the X value. So on question number 20 then, okay, I've got that just off to the right side here. I know that my number of trials is N. So I type in 15, okay, enter. P is 1/3, so I can type that in as 1 divided by 3, enter. And my X value is 13, enter. Now, where it says paste, what it's literally doing is pasting it into the formula that it already has in memory. So I'm going to go ahead and hit enter. And there it is. It pasted into the formula. And then I'm going to hit enter again. Okay. And I get a value of 2.93, and it says e to the -5th. Okay, remember that's standard notation. So I'm going to move that thing to move the decimal point of that 5 times in the left direction. So as a decimal then, that's 0.0000 and 293. Okay, so right again, it did all the work for me. All I needed to know were those 3 things: what's N, what's X, and what's P. Now, why can't I use the table for finding all of these? Well, so either the P value is not going to be in that one of those columns at the top of one of those columns, or N's going to get bigger than what your table will handle. Okay, but either way, this thing will work for everything. So it's Binom PDF. It is under the VARS button. You have to go second VARS, and notice the title above that VARS button. It's distributions. Okay, so it's literally putting these are probability distributions, binomial probability distributions, and it's with all those other ones. Okay, so that's how you're going to find those values. Okay, and then it gets into some story problems down below. Again, I would recommend just using the calculator again. So on number 24, in the directions up there, it says when blood donors were randomly selected, 45% of them had blood that is type O. The display shows the probabilities of obtained by entering the value of 5, and P is 4.45. Okay, so with that, it says number 24 says put it where you can see it. Okay, find the probability that at most 2 of the 5 donors have group O blood. At most. Okay, so can it be less than 2? Absolutely. It cannot be greater than 2. So what I'm trying to do here is I'm trying to find the probability when it's equal to 0, the probability when it's equal to 1, and the probability when it equals 2. And I'm going to add those up to find the probability for the total probability of at most 2 of the 5. So I'm going to go to the calculator and I'm going to do this thing 3 times. So when I plug in 0, this thing has 5 trials, and my probability is 0.45, and I want my X value to be 0 for this first time. Okay, I get 0.0503. Okay, I'm going to do it again. Second vars down to the Binom PDF button. I'm going to go 5.45 and 1, and I get 0.2059. Okay, and then I'm going to do it one more time using x equals 2. Okay, now, again, what this formula does, it finds the probability for that exact value. So that's why I'm having to add all of these up. The question is asking for more than that one value and wants to know any of those that are possible. And so we're looking at the combination of all of those. And that's why I need to go through this addition process. And I get 0.3369. Okay, so I took them all out 4 decimal places here, just so that I could get a little better, a clearer picture. And I get 0.5931 then as my final probability. Okay, on my answer sheet, I just rounded that to 0.593. But either way, you know, all we're doing is we're calculating probabilities. We're trying to determine differences in distributions that are binomial and not binomial. We're going to do some more with calculations on those, on finding mean, standard deviation in the next section. Okay, but it'll just be a little bit more of the same kind of stuff. Okay, so email me any questions you have on these. Thank you.